and greetings everyone. My name is Nurfaraliyana Binti Samburi and my supervisor, Technologist Dr. Ahmad Fateh bin Mohamad No. My research title is Optimizing Voltage Stability Analysis to Predict Blackout Risk using VCPI. Now, let's separate the title into three parts. First part, Optimizing Voltage Stability Analysis, refers to analyzing the voltage parameters. Next part, to predict blackout risk. What is blackout? It is the loss of electricity. It means that no power supply to homes, office that depend on electricity. So, that's why we need to predict the risk by using VCPI, which it is a technique to measure whether the voltage is stable or not. The use of electricity is increasing every year. Electricity is used to turn on lights, charge phones, run appliances like fans, TVs, laptops, and other devices. As we use more electricity, power systems need to produce more energy to meet consumer demand. The power system refers to a network that includes generators, transmission lines, and distribution systems to deliver electricity to consumers. Following by the current trend, an example for today is that the construction of new house in the housing area is also increasing. As a result, the amount of electricity can be supplied to household will continue to rise. Therefore, to ensure sufficient electricity can be supplied to all new house, this topic will be an important discussion in this video to ensure the stability of electricity and prevent blackout from occurring. Now, let's move to the problem statements. The electricity system is running close to its limits. The main problem during this time was blackouts, which caused consumers to lose access to electricity. Therefore, identify the weakest load bus in the electricity system because it cannot be determined simply by looking at their initial voltage values. The objective or solution for this problem: perform voltage stability analysis using the Voltage Collapse Proximity Index VCPI on an IEEE 57 bus test system. For the detailed explanations, what is the bus? Bus act as electrical connection points that allow electricity to flow. What is the weakest load bus? The bus in the electricity system are not in good condition. If more houses are built, blackouts could occur due to insufficient electricity supply. What is the Voltage Collapse Proximity Index VCPI? It is a technique used to measure whether the voltage level is stable or not. According to the VCPI reference, the value close to 0 means the system is stable, normal electricity flow, and no risk of blackout, while the value reaching to 1 means the system is unstable, having the abnormal electricity flow and higher risk of blackouts. All the VCPI values are expressed in per unit. Novelty and academic contribution. Number 1, enhancing grid reliability and resilience to ensure a stable and uninterrupted electricity supply for consumers. Number 2, utilization of VCPI as a technique for analyzing voltage stability rather than observing voltage values. Impacts to individual, it's relate on cost saving to avoid losing electricity, which can cause additional expense when using a backup generator. Impacts to society, it can increase the public safety by keeping electricity running to power things like traffic lights and emergency service. And lastly, impacts to nation by support the economic growth by providing a stable power supply for factories, business, and essential service. This project can be commercial to power system designers. It can determine the amount of electricity supply required for a specific area, such as a new housing development, to ensure there is enough power to meet consumers' need. Next, commercial to developers. For example, developers plan to build 100 new houses. The designer check if the area has enough electricity to support them. Once designer confirm it can support the needs, the developers can proceed with their plan to build. This project has collaborated with the company Recatonic, which serves as the industry partner. This collaboration aims to support academic and innovative initiatives, showing that the project has potential for commercialization. This project tests using a 57-bus system model. All the data for the model was taken from the reference book. This is the complete code for the project. The code has been adjusted to match the 57-bus system data. The first result displayed after running the MATLAB code is the voltage magnitude for each bus. In the standard range, voltage magnitudes should be between 0.95 and 1.05 per unit to be considered stable. For the further explanation from the previous graph, there are 5 buses outside the voltage magnitude standard range. The reason is that these buses are located farther from the generation switch. Since the buses are connected, a bus with a lower voltage can affect the performance of nearby bus. Next, proceed with the VCPI calculation using the formula. Here is an example of the calculation for bus number 5. According to the second results, bus 23 has a VCPI value close to 0, means system stable and no blackout issues, while bus 18 has a VCPI value reaching 1, means system unstable and blackout occurs. Why are there lines A and B in the graph? Because bus 18 and bus 25 are interconnected through 2 transmission lines as shown in the diagram above. Therefore, bus 18 identified as the weakest bus. The weakest bus is not included in the list of the 5 buses outside the voltage magnitude standard range. This is because the 5 buses are identified based on the IEEE 57 bus system, while the VCPI analyze the voltage stability by using the different perspective. This indicates that bus 18 in the electricity system is not in good condition. The blackout could occur especially if more houses are built and the demand for electricity increase. This is because there is insufficient electricity supply. Therefore, as a future recommendation, address the electricity issue at bus 18 to prevent blackout by installing a solar photovoltaic system. Solar PV offer many benefits, especially in minimizing environmental impacts.